right, lesson 9.8. And the final test for convergence and divergence, something called the ratio test. So the ratio test is actually a very useful test if you have series that involves factorials or exponentials. Okay? And what the ratio test says is if you take the limit as n goes to infinity of the next term divided by the current term, okay? And you take the absolute value because you don't worry if it's plus or minus. Well, if it's less than 1, then that series converges. If it's bigger than 1, or of course infinity, then it diverges, right? So you're really thinking about the ratio of the next term to the current term, okay? The ratio is less than 1, converging, bigger than 1, diverging, and if it's equal to 1, that's the problem case. We have no idea. Inconclusive. Try another test. Okay, so understanding that, let's take a look at example 1. Once again, you see a factorial and exponential. That's why the ratio test is used. So let's go ahead and set up the ratio here, please. The ratio would be the limit as n approaches to infinity of the absolute value of, and it's the n factorial over 3 to the power n. We're going to divide that by, yes, my mistake. I made the fatal mistake. It's the next term. Oops. So, that's right. The nth plus 1 factorial all over 3 to the power n plus 1. And then you're going to divide it by the current one, n factorial over 3 to the n. Now, this is kind of messy, so it might be nice if we can rewrite this a little bit nicer. N plus 1 factorial over 3 to the n plus 1 multiplied by, yes, the reciprocal, so 3 to the n over n factorial. Nice. Now, I hope you can see that there's some simplification that's going to happen here. Notice the 3 to the n and 3 to the n, right? That just leaves a 3 to the power of 1. And the n factorial with n plus 1 factorial just leaves an n plus 1. So ultimately what you have here is the limit as n approaches to infinity of n plus 1 all over 3. And if you think about what happens here, when I plug in infinity, this actually becomes infinity. Yes. So therefore, what do we know? I'll say by the ratio test, this series, the sum of n equals 0 to infinity of n factorial over 3 to the n, that's right, diverges. There you go. Okay. So why don't you take a look at number 2 and try that yourself. It's the same process, so go for it. Remember, don't make my same mistake as I put the wrong thing in the numerator. So this will be the nth plus 1 term. So nth plus 1 gives you the power of n plus 2. 4 to the power of n plus 1 times n plus 1 all squared. And I'm going to divide this, or actually multiply by the reciprocal, so I can just save myself a step. So I just write the denominator in the numerator, and then also the numerator in the denominator. Good. And now we're set to simplify. So I hope you can see that the 4 to the power n plus 1 gives you just a 4. The 3 to the power n plus 1 and the 3 to the power n plus 2 just gives you a 3 on the top. And I think that's all we can do. So now we have the limit as n approach to infinity of 3n squared all over 4 times n plus 1 squared. Notice I don't really need the absolute value anymore. I know these terms will be positive. But if I were to simplify this, remember n plus 1 squared is really, well, I could expand this out, but, well, okay, I will. I guess I will. N squared plus 2n plus 1, right? Do I really need to worry about this? No, because using the n behavior model, hope you remember that the limit as n approaches to infinity just becomes 3n squared over 4n squared. Yeah, That's just 3 over 4, which happens to be less than 1. So therefore, by the ratio test, this series, what is it? What is it? What is it? Yep, it converges. Cool. All right. Well, number 3 is the same, similar. Go ahead and try that. So remember here, because we have the absolute value, we don't really worry about this negative 1 to the power n, right? So I'm just going to go absolute value of, and then root n plus 1 over n, and divide that by the current term, which is multiplying by its reciprocal. And then if you think about what happens here, I'm going to use the n behavior model again. The highest power of n in the top would be what? I think n times root n, so that's like n to the 3 halves. Weight is the same in the bottom, and wait, this is a problem because it equals to 1. Ratio test is a flop. It's inconclusive. Can't do it. So unfortunately for this one, you're going to have to find another way to figure out if this is convergent or divergent. Do you notice that lovely thing I circled? Negative 1 to the power n? That means the terms must alternate in plus and minus. Okay, so what test could we possibly use? Maybe the alternating series test? Yeah. I guess the next thing you should think about is the idea of root n over n minus 1 decreasing. Well, you can use the derivative to figure that out, but I can tell you that it is, because the root n part is, remember the graph, right? Like this, n minus 1, straight line. So this kind of flattens out, so the ratio, of course, gets less and less and less. So yes, I'll say to you, I know that the root n over n minus 1 decreases. And what else do we need for the alternating series test? Oh yeah, we have the alternating signs. Terms alternate signs. And finally, what else do we need? Yeah, the limit as n approach to infinity of the root n over n minus 1. And yes, I know this does equal to 0. So therefore, by the alternating series test, going back to something you did earlier in the unit, this does converge. So maybe I'll just write it out. I'll say therefore the sum of n equals 2 to infinity, negative 1 to the power n root n over n minus 1 converges. Okay. Once again, in this case, ratio test didn't help me at all because the ratio was equal to 1. All right. Ooh, number 4. What is this double factorial? Well, I've told you what that is. The double factorial means you skip every second, or you don't skip, but yeah, you do skip. It's every second value. So we'll still start off with 2n plus 1, but this time we subtract 2 before we get our next one. So that'll be 2n minus 1. We keep subtracting 2, and notice you get 5, 3, 1. Okay? So how can we do this one? Once again, let's set up a ratio. The limit of n approach to infinity. That's the value of, and I guess it's that 2. And remember, it's the next term. So I'm going to replace n with n plus 1. So if I multiply that by 2 and then plus 1, I get 2n plus 2 plus 1 is 3. So 2n plus 3 factorial, or double factorial, all over 3 to the power n plus 1. And then once again, this n becomes n plus 1. So that's 2n plus 2 minus 1. That becomes 2n plus 1 times n plus 1 factorial. So that's what I have as the next term. We'll divide this by the current term, which means I'll flip it around. So 3, 3n, 2n minus 1 2n factorial on the top, 2n plus 1 double factorial on the bottom. Okay, let's try to simplify. Now, I'm looking at these double factorials. I think that just simplifies to, yeah, 2n plus 3 in the numerator, right? What else can we simplify? 3 to the n, 3n plus 1. That simplifies to just a 3, right? What else can we do? Well, the n factorial and the n plus 1 factorial leaves us with a factor of n plus 1 in the denominator. And then that leftover part of 2n minus 1, and then also the 2n plus 1, we can't really simplify that, so we'll just leave it like that. Leave it there. And now, can we evaluate this lovely limit? I hope we can. Once again, using the n behavior model, we're just going to take the highest power. So the highest power in the numerator would be 4n squared, right? 2n times 2n. And in the denominator, I have n times 2n, which is 2n squared. But there's also a factor of 3 in front, so 3 times 2 is 6n squared. And if I simplify this, this becomes just 2/3. That is definitely less than 1. So, by the ratio test, the sum of n equals to 1 to infinity of this 2n plus 1 double factorial all over 3 to the power n 2n minus 1 times n factorial must converge. All right? That, my friends, are the tests for convergence and divergence. And just like how you learned integrals, remember how you learned integrals with all those different techniques? Now we're going to mix them all up. And yes, once they're mixed up, you still need to figure out how to go about choosing the right test, and then applying the test, and then figuring out if it converges or diverges. Wow. So when you're looking at these mixed problems, I like to go through this little kind of like a checklist, I guess. I ask myself first, does the nth term approach 0? If not, then let's use the series diverging nth term test to show that it diverges. Okay. Then I look to see if it's a special type. Is it a geometric series where there's a factor of r, the common ratio? Or is it a p series? Or is it alternating? Because if I can identify what those are, boom, I just use that, we're done. Then I say to myself, okay, can I use the integral test? If it's something that looks like an integral I can do quite simply, go ahead, do that. Or is it the ratio test, because it involves factorials or exponentials? And then last but not least, I look at this and say, can I compare it to a special type of test using a direct comparison, meaning comparing larger and smaller series, or a limit comparison? That's the one with messy algebra where I'm trying to simplify it into a p-series and then compare it that way. So that's what I think. I go through this list as I look at the question. All right. And now you're going to try that yourself. Okay. Once again, here are all the tests. Okay. Summarize it all here for you. So maybe cut and paste this and stick it in your notes. It's already in your notes. I mean, stick it into your brain and make it stay in your brain. Okay. Oh, so many things, so many tests. And now, yes, I'm actually going to let you try these yourself. Okay. Yes, you try these yourself. And if you're stuck, come for hints. Okay. So once again, press pause and then come for hints if you're not sure. Okay. Press pause. All right, you're back for hints, aren't you? Well, I'll give you maybe some hints. Okay, for number 5, my hint to you is I will take the limit as n approach to infinity. That's what I would do, which means you're using the actual nth term test. Okay, here's my hint. 6. Well, I have here e to the negative n cubed and then n squared. That kind of looks like a substitution integral. So that word integral is my hint. Number 7 looks like something to the power of n. So that means as I make n larger and larger, there seems to be a common ratio. So think about what test you can use when you see a common ratio. 8 has messy algebra. So I'm thinking, compare if you dare. Compare maybe to something simpler. There you go. And number 9, -1 to the power of, that's usually a plus and then a minus and a plus and a minus, perhaps alternating series tests. And then for number 10, wow, what is this? If I were to simplify this, n factorial over 10 to the power n. Actually, that's not simplifying, that's generalizing. I see factorials, I see exponent. Got it, what we just did today, the ratio test. Okay, so you wanted hints? There are your hints. I don't really want to do the rest for you, but should I? Well, maybe I will really quickly, but you're still going to have to press pause because I still want you to try it yourself first. Listening to me is one thing, trying it is another. I think trying it yourself is better. I'll wait for you. Nth term test. That just simplifies to by the n behavior model n over 2n, which equals to 1/2. That is not equal to 0, so this is diverging or divergence by the nth term test. I told you this is about substitution. Those of you who are like, oh, I remember reverse chain rule. Sure, I can do that really easily. Let me just write this down like this. Oops, that looks ugly. E to the negative n cubed. Remember, reverse substitution means if u equals to negative n cubed, then I need to have a u prime, which is negative 3n squared. I've got my, oops, I really shouldn't be combining n and x, right? Sorry, x, x, x. I got x squared, but I don't have that negative 3, so I'll put that here. But wait, I gotta balance it out, so I better put a negative 1/3 in front, right? Don't forget your dx, and then by reverse chain rule, this just becomes the limit of b approach to infinity, negative 1/3. And this is just e to the negative x cubed. We're going to evaluate this from 1 to b. I forgot the limits. And then you plug this in. Negative, what's that? B, negative 1/3 e to the negative b cubed minus negative 1/3 e to the negative 1. Well, that infinity cubed is going to be just e to the negative infinity is 0. So that term is just 0. 0 plus 1/3 e is really 1/3 e, which means that this is a number. So therefore, this series converges by the integral test, IT. Number 7, I gave you a hint. There was a common ratio, so I hope you can realize that the common ratio is E over E. Now the question is, E is approximately 2.718 over 3, which is less than 1. So by the geometric series test, I know that this also converges. Cool. And then number 8, we're looking at a comparison, what we did in the last section. So I'm comparing it to 1 over n. That is the harmonic series, or P series equaling 1. So therefore, this one is divergent. So now let's see if we can compare. How do you want to compare? Well, I can do the limit comparison test. So n approach to infinity, 1 over 4n plus 5, all over 1 over n. What do I get here? N over 4n plus 5, n behavior model. So the limit as n approach to infinity of n over 4n, which actually just equals to 1/4. That's right, finite, positive. So they follow the same idea. So therefore, the original series, n equals 1 to infinity, 1 over 4n plus 5 also diverges too. Okay. All right, 9. I gave you the idea of AST, right? Yes, so hopefully you can see that the terms alternate sign. I hope you can also understand that 3 over n squared is decreasing. And once again, you can take the derivative if you want to show that this thing's decreasing all the time, right? Or you can just look at the terms, write them out and see. But we know this definitely decreases. And then the last thing I need to check is that the limit as n approaches to infinity of 3 over n squared, that definitely equals to 0. So therefore, by the alternating series test, we know this also converges. I shouldn't say also. I should say this converges. I'm not comparing to anything else here, right? This is the alternating series test. Okay, and number 10, this is like what we just did today. You bet. Taking the ratio test. N plus 1 factorial over 10 to the power n plus 1 divided by n factorial over 10 to the n. Big absolute value. What an ugly way of writing it. So we'll convert it to this. And then let's do some simplification. Yep, n plus 1 on the top, just a factor of 10 on the bottom. When I actually take the limit as n approach to infinity, this just becomes infinity. So therefore, by the ratio test, you bet this diverges. Okay, so you might not be very good at identifying them all right now. That's okay. This is just where you just need some practice, right? The more you do, the more you see, the more you can connect. Once again, I would suggest you have this page with you, this little checklist, handling mixed problems, and all the different convergence, divergence tests that you can use. Okay? Yes, it's time to practice on your own.